Hey guys, in this video we are going to review the Henderson Hasselbach equation and what is the predominant species and what is the average molecule. First, let's review what is the pH value. pH is simply equals to the negative log, the concentration of hydrogen ions in the aqueous solution, and K, which is also known as an acid dissociation constant. So K equals to the concentration of the hydrogen ions times the concentration of ionized form of the weak acid divided by the concentration of unionized form of the weak acid. So as for pK, we just change it into the log form. So pK equals to negative log Ka. Let's look at the diagram of the relationship between the pH and pKa. We can see from the diagram as the pH decreases, the pK also decreases, which means as the pK is getting smaller, the acidity of the solution is getting stronger. Let's solve for Henderson Hasselbach equation. So we start from the Ka value and we do a ring arrangement and add log on both sides. So we get to this point. According to what we have learned in high school, if we want to change the position of the numerator and denominator in log, we just simply add a negative sign in front of the log. So we get pH equals to pK plus log concentration of ionized form of the weak acid divided by the concentration of unionized form of the weak acid. Okay, let's do a problem. So the problem set is all under certain conditions. First, so it's under the standard condition, which is the 25 degrees Celsius and 1 atmosphere. So as for condition 2, it is for easier calculation. If the pH value differs from a pK value by plus minus 2, assume completely protonation or completely protonation respectively. So let's go over this condition. Also, we used the Henderson Hasselbach equation we just got from the previous slide. And we do a rearrangement. First, pH minus pKa. We plug in 2. The 2 equals to log the concentration of ionized form of the weak acid divided by the concentration of unionized form of the weak acid. And then on the left side, it's 10 to the power of 2 equals to the ratio of ionized form divided by unionized form. So, we know the concentration of ionized form of the weak acid is 100 times larger than the concentration of unionized form of the weak acid. So under this condition, we assume the weak acid is completely ionized, or in other words, is completely deprotonated. And then we can try to plug in the negative 2. So under this condition, the ratio change into the 10 to the power of negative 2, which means the unionized form is 100 times larger than the ionized form. So in the aqueous solution, then it is 100% completely of unionized form. Okay. And let's look at the question 1. So below is the structure of the fully protonated form of the antibiotic penicillin. It has one ionizing group with a pK of 2.6. Identify and name the single ionizing group. Name both the unionized and ionized forms. Okay, according to the diagram, pK is 2.6, which means the pH value is smaller than 7. So the ionizing group must be an acid. So it must be the carboxyl group, because this one is an acid, right? So the unionized form is called the carboxyl group, and the ionized form is called the carboxylate. Okay, and say, okay, the unionized form is the carboxyl group, and the ionized form is carboxylate. And then we look at question B. What proportion of penicillin molecules have the ionized form of the ionizing group? You identified in A at stomach pH of 2, intestinal pH of 6, and blood pH of 7.4. For this question, we simply use the Henderson Hasselbach equation and plot in the number. So let's look at pH of 2. So pH equals to pK equals to 2.6. We just simply plot in the number. So on the left hand side to right hand side, we replace the pK value to 2.6. And we do the rearrangement and get a ratio of ionized form, and unionized form is 10 to the power of negative 0.6. And as we already know, the unionized form is the carboxylate, and unionized form is the carboxyl group. And so the ratio of carboxylate and carboxyl group is 10 to the power of negative 0.6. But we have to figure out the proportion. The proportion is actually the carboxylate over the carboxylate plus the carboxyl group. So we have to do the rearrangement. So we simply assume the concentration of carboxylate is 10 to the power of negative 0.6, and the concentration of a carboxyl group is 1. And then we plot in the number. After the calculation, it equals to 20%. So we get the answer of 20%. And the next question, the pH of 6, we don't need to further calculate it because the pH value differs from the pK value is larger than 2, right? For pH of 7.4, the difference is also larger than 2. So it is completely deprotonated. So in the aqueous solution, it's 100% of carboxylate. Okay, we take pH equals to 6 as an example. So we just simply plug in the number, pH equals to 6 and pK equals to 2.6. And we do a rearrangement. We get the ratio of ionized form and unionized form. So it's 10 to the power of 3.4. Under this condition, we will assume an aqueous solution is completely the ionized form. So it's completely deprotonated. So the ionized form of the ionizing group is 100% under this condition. Needless to say, the pH of 7.4 is also 100%. And draw the predominant species and average molecule. So at pH of 2, according to the calculation we just did in question B, so a ionized form, which is carboxylate, is only 20%. So 80% is the unionized form, which is carboxyl group. So we just copy this whole structure down to our answer sheet. Okay, this is predominant species. And average molecule. According to the calculation, we have 20% of ionized form, which means the negative charge is 0.2. Okay, so let's look at the answer key. Yeah, 0.2. Because the aqueous solution contains 20% of the ionized form. And let's look at the pH equals to 6. So according to the question B, in the aqueous solution, it contains completely 100% of ionized form. So we change the H into a negative sign. So this one is the predominant species. And average species, since the ionized form is 100%, so average molecule, we just need to write down -1 here. Okay, let's look at the answer key. Yeah, here. So needless to say, the pH equals to 7.4, which is the same. Okay, and this is how we get the predominant species and average molecule.